Right, we've got an inequality and two equations to solve here. First of all, let's deal with what is a quadratic inequality. Step one is to factorize it. So it's going to become x plus 3, x minus 2, greater than 0. Now, if we plot y equals the left-hand side, this would be what it would look like. We'd get a root of minus 3 and 2, because it's where x plus 3 is 0 or x minus 2 is 0. And if I sketch this as a happy quadratic, so it would look a little bit like this. Where is that graph greater than 0? Well, it's either here or here. And from that, it's, giving detailed reasoning, I can clearly see that either x is less than minus 3, or, and we definitely need an or, not an and, or x is greater than 2. I can't combine them into a single inequality, that's it. I've been asked to write it as set notation, which is different than interval notation, by the way, and this would be how we'd write it. The set of x such that x less than minus 3 intersected, which means combined with the set of x such that x greater than 2. Let's take a look at B. This equation does not look very nice until you realize that x cubed is actually x to the power of 3 over 2 squared. And then we can see that it's actually going to be a hidden quadratic. It's in the powers of x to the 3 over 2. So I'm going to do a substitution. Let t equal x to the 3 over 2. So t squared minus 7t minus 8 equals 0. And t minus 8t plus 1 equals 0. So t is equal to 8 or minus 1. Now let's get it back in terms of x. That's going to mean that x to the 3 over 2 is equal to 8 or minus 1. But the minus 1 one, well, if you think about it, if you've got x and you cube it and then you square root it, or you square root it and then you cube it, it's always going to be positive. So this one we need to reject. Because this means the square root function, which is always a positive square root. So reject that one. So to get x, we're going to do the inverse. X is actually going to equal 8 to the 2/3, which is the cube root of 8 squared, because it's 8 to the 3rd then squared. So it's going to become 2 squared, which is 4. And that is our answer. Finally, we've got an exponential equation to solve. Sorry, bear with me. Okay. First things first. I mean, actually, there's lots of ways you can answer this question. But it's asked for the exact solution. First thing I'm going to do is write it as 3 to the 2x. They're the same thing. Because it will now be more easier to take logs. I'm going to take the natural log. It's going to become ln 3 to the 2x equals ln in brackets 3 times 2 to the x. And I've done this because now I can bring that 2x down. I can use the third rule of logs, 2x ln 3. And then the first rule on this one, ln 3 plus ln 2 to the x. And then I'm going to actually bring the x down on that one to write this. And I've gone from an exponential equation to a linear equation. Now, how do you solve linear equations? It's a bit like back in the day when you first learned how to solve 5x plus 1 equals, I don't know, 3x plus, or let's just say 3x. you could minus 3x from both sides and you get 2x plus 1 equals 0. It's the same idea here, but it looks a bit more complicated. But what I can do is I can write it as x. Actually, let me leave it as it is. 2x ln 3 minus x ln 2 by minusing this from both sides equals ln 3. Factorize out that x. You know, it's more awkward, but that's kind of what you're doing here. 5x minus 3x, you factorize out the x to give x times 5 minus 3. It's just a bit more complicated here. And then finally, x is equal to ln 3 all over 2 ln 3 minus ln 2. And that would be an exact answer. You could combine the logs down here if you wanted, so it would be ln 3 over ln 9 by bringing that 2 up minus ln 2, or ln 3 all over ln 9 over 2. You could argue that that is more concise, but you know, that box is fine. Now I know I did it in natural logs, but you could also have taken log to base 3 or potentially base 2. You get a slightly different answer. I guess the best thing to do at this point is whatever your answer is, as long as it's exact, you know, just put it into a calculator and see if it is the same as mine. I'm going to show you the mark scheme, and you know, then you can see some other potential ones. So if you took log to base 3, it would have looked like this. Arguably, that is the simplest. You might also have actually have written it as 9 to the power x divided by 2 to the power x, and then taken log to base 4.5. Actually, maybe that one's the simplest, but you're taking log to a decimal. So any of these, as long as you've followed the process, or if you've got a different answer, which is possible, then just check by substituting it. But I hope you're happy with those questions.